All right, I believe we're recording now. My computer looks like it's going to be able to handle it. I'm looking at my specs here. It's looking like it's going to be able to do this. And you know, we're making this video so that Rylan can watch it. So I figured I would just go ahead and give Rylan a shout out. There you go, Rylan. That's just for you. Okay. It went a little further than I thought it was going to. All right. So let us continue down Trig Avenue, right? We need to be able to use the stuff we did yesterday. Well, we graphed tangent, cotangent, secant, and cosecant. We finished up by graphing secant and cosecant. One of the things that we can do with this is we can solve some trig stuff algebraically. We can solve by hand, no calculator necessary. So that's where we're going to start. We're going to find the value of x that's between pi and 3 pi over 2 that solves the equation. Now pi and 3 pi over 2, that is in quadrant 3. So I'm going to go ahead and sketch up quadrant 3, maybe. Let's see if the pen works. All right, we're in quadrant 3 here. Here's pi, and here's 3 pi over 2. There. And we say that we know secant is equal to negative 2. Picture not drawn to scale, of course. Secant is the reciprocal of cosine. So since cosine's x over r, secant must be r over x, not to be confused with this x, talking about the adjacent side. So it must be negative 2 over 1. Negative 2 over 1. Well, the radius can't be negative. So the radius must be positive 2, and the adjacent side must be negative 1. So if the triangle has a radius, aka hypotenuse, of 2 and an adjacent side of negative 1, then what does the length of this side have to be? A negative root 3, and it's negative because of the quadrant that it's in. All right, negative root 3. Wow, now I know why the video looks so bad. Everything is stretched vertically. That's the issue. Yes, vertical stretch factor potato. Let's see if I can fix it. Let's see if I can fix it. Alrighty, well, the efforts to fix this video are no good. I'll have to figure out something better in the future. So unfortunately, everything I write today is going to be vertically stretched for you guys. My apologies. But anyway, we were trying to solve for the angle that's going to produce this, right? Well, the reference angle that is in this kind of triangle that's across from the root 3, I'm hoping everybody's memory has been jogged since we were having fun trying to fix the video. But during that time, I'm hoping that everybody realized that across from a root 3 is always a 60-degree angle, right? That's the reference angle. But we want to solve this thing in radians, right? So 60 degrees would be what in radians? It's pi over 3. Well, this is actually a pi over 3 after pi. This is a pi over 3 after pi. So x would have to be pi plus pi over 3. And common denominators is going to give us pi over 3, or 3 pi over 3 plus pi over 3, which is 4 pi over 3. There we are. So it's not that hard. That's it for that one. Yeah, that's it for that one. We just had to make sure that the triangle was drawn in the right quadrant, and then, what sides does secant use. In fact, we've done stuff like that before without graphing. So why is it in these notes, right? Well, it's in these notes that way you can see that we can also do this stuff with graphing. Man, this ratio, the scale on this is so bad. Ugh. Anywho, turn on the calculator. Because none of this stuff is in degrees, when we graph these things, we need to be in radians. So you want to make sure that your calculator's in radian mode, and mine is already in radian mode. And because I taught this in period 1, I already have the two functions typed in. I have x squared, and I have 1 over sine of x, because the graphing calculator does not have cosecant of x as an option for it. Now, the real question is going to be, what would be a good window, right? I think the hardest part for a lot of people when graphing is trying to figure out an appropriate window. Well, the TI graphing calculator comes with a very specific type of window for trigonometry. If you look down at number 7, it says trig. So we're looking for zoom trig. And when you use zoom trig, what it does is it puts your x-axis in fractions of pi. So I'm just going to hit 7, and it's going to graph my two functions. There's x squared, and there's cosecant of x. There you go. And we were supposed to find the smallest possible number. Well, I'm hoping that it's obvious that that answer is right there. And we find intersections by using second, trace, intersect. Second, trace, intersect is number 5. First curve, it says, yo, is the first curve this parabola? And I go, yes. And it says, is the second curve, now look where it is. You see how it says x equals 0, y equals, and it's blank? That's because cosecant doesn't exist when x is 0. So what I'm going to have to do is hit the right arrow, and now it is somewhere on the cosecant curve. You see it? See how now it says 1 over sine x, and it actually gave me an x comma y. So I know the cursor is somewhere on the red curve now, so I'm going to say, yeah, that's it. I just hit to the right. I hit the right arrow. Oh, you can't see the right arrow. I was pointing at it with yeah. I hit the little right arrow, which I'm going to hit a couple times now to move the cursor closer to where I think the answer is. That's pretty close. About 1.068. And honestly, that's all we do for this question.
Is there a way to solve it without a calculator?
No, there is not a way of solving it without a calculator, without using something called successive approximations, because it's an irrational answer. I wouldn't even know how to begin, to be honest with you. But there you go.
At the beginning,
Oh, at the beginning, yeah. But that's it. If it says solve graphically, that's what we expect you to do. Will you be doing this on my test? No. So why bother teaching you? Because no matter what class you go to after this one, whether it be IB Math or AP Calc or even Prob and Stats, should you decide that you don't even like this kind of math at all, this calculator is going to be your friend. So you need to know how to use it. But we're finished with it. Hold on, I just got these lips. I'm sorry. You are finished with it for today. So let's focus on graphing. Let's do some graphing. So this is a graph of a cosecant function. If you remember to yesterday, the way I graphed my parent cosecant function was I used a ghost image of its reciprocal, which is sine. Cosecant is the reciprocal of sine. So what I'm actually going to do is I'm going to go through all the steps that I would have gone through for graphing sine instead of cosecant. And once I have my ghost image of sine on there, I'll just basically turn the curve inside out to produce the graph of cosecant. So we're working with y equals -2 sine of 4 times x plus pi over 8 plus 1. I'm going to graph a ghost image of sine because sine is the reciprocal of cosecant. Not so much flip it, but remember wherever sine was 0, cosecant had asymptotes. So basically wherever sine is on its midline, I'm going to draw asymptotes. And wherever sine had a maximum, I'm going to draw a cup that goes up. And where sine had a minimum, I'm going to draw a bell that goes down. Just like that. So all the work that I'm going to be doing is for this, for sine. I like to identify my midline and amplitude first. The midline for my ghost sine is y equals +1. And my amplitude is just going to be 2. That means that my maximum is 2 above the line y equals 1, or 3, and my minimum will be 2 below the line y equals 1, or -1. So my y values on the x-axis, or y-axis, they can just go by ones. 1, 2, 3. My maximum will be on 3. 0, -1. My minimums will be on -1. I have no reason to put any other numbers on there. You know what I should do? I'm going to go ahead and put the midline of the ghost sine wave, and I'll do that in green. Got to use lots of colors. There. That'd be the midline of the ghost sine wave. Now we need the period. The period of sine is 2 pi over b. So 2 pi over 4, which is pi over 2. The period of our sine and cosecant will be pi over 2. Okay, well, since we're talking about a ghost sine, I need to figure out where my quarters go because this is how I'm going to determine the scale of my x-axis. My quarters will take my period length and cut it into fourths. So pi over 2 times pi over 4, which is pi over 8. My quarters will happen every pi over 8, and guess what? My phase shift is also a pi over 8. So they already have a common denominator. Life is good. Life is good. Now remember, we're talking the sine wave, okay? We're always supposed to start this at what makes the inside equal 0. That's negative pi over 8. So we're going to quote-unquote start at x equals negative pi over 8. Since it's a negative sine wave, is it going to begin on a maximum, a minimum, or a midline? Midline, and since it's a negative sine wave, where is it going to go from the midline? So it's going to go midline down. There it is. Cool. Since my phase shift and my quarter marks have the same denominator, I'm just going to go ahead and go by pi over 8s. And I have to begin at negative pi over 8. So there's negative pi over 8. Here's 1 pi over 8. 2 pi over 8, which of course would reduce to pi over 4. 3 pi over 8. 4 pi over 8, which of course would be pi over 2. 5 pi over 8. I think I'm going to go all that to 7. 6 pi over 8 and 7 pi over 8. There. This is a ghost wave, so I'm not going to use a pen for this, and I don't want it to stand out too much. But we do know that we're going to start at our midline for our sine wave, and we're going to head towards our minimum. So we're going to start here, and then go down to our minimum. Back up, maximum, midline, minimum, midline, maximum, midline. There we go. Ghost sine. When we were graphing the parent cosecant wave, what we did was we said every time sine hit 0, which is also its midline, you had an asymptote. So we have a vertical asymptote every time this sine wave hits its midline. Now, to sketch the cosecant. I'm going to turn my sine wave inside out, I like to say. Inside out. And there it is. Not too bad, right? It's a lot of work, don't get me wrong. I would never say that it's a fast process, but it's a methodical process, and you know, as long as you understand what was going on, you will remember this next year. Is it as fast as memorizing where the asymptote should have been and where the, you know, tick mark should have been? No, it's not as fast as memorizing, but I can guarantee that I'll still know how to do this in 3 months compared to just trying to memorize it. Questions on this one? Are you guys ready to go to the next one? Yes, sir. What can I do for you?
When you did the quarter, why did you do pi over 4?
I meant to say 1 over 4, not pi over 4. My apologies. Good catch on that. Woo. Well, you should have said something. It makes me look stupid. Yes, Bryce.
Questions like this be on the test?
Questions like this are on the test.
No, but how, like, are they
Oh, it would be multiple choice. Like here's an equation. Which of these is its graph?
Okay.
Or it might be here's a graph. Which of these is a cosecant equation for it? So it could be either or. Yes, Thomas. Oh, why did I do 2 periods? Just so I could get a better idea of what the picture looks like. That's the only reason why. Because, like I said, 1 period is if you know exactly what 1 period goes, you're in good shape. I just wanted 2 periods because it makes for a good picture. Yep.
So is it the blue like
I can't even hear you. You're right in front of me. What's up?
is the blue is
Yeah.
that like the is it the CSE?
Oh, the blue is cosecant, yes.
Okay.
And the red. The red are its asymptotes, and the blue is where the curve actually is. I just do the pencil, the ghost image, because it shows me exactly where my asymptotes go and where my dots are. I'll be real with you. Without that ghost image of sine, I wouldn't even be able to tell you how long this would have taken me to do. Because it would have been a whole lot of trying to figure it out. A whole lot. Let's do it again, only this time we will use a secant function. Yes?
So would Miss Klein's kids, since they have to memorize,
Yeah?
would they do as advanced problems as us? Or is it like if
Oh yeah, she has them do it. She has them do just questions just like this, but the difference is she has them memorize where cosecant has its asymptotes
yeah,
and where its points were,
yeah.
and then based on their memory, she has them transform that. And I can't do that. I'll be real with you. It's too much to remember. I can't do that. I can't fill my brain with what I consider to be useless information. Oh, where's this asymptote? I don't know. I don't need to know. You know what I mean? The sine wave will show me where that asymptote was. Why would I bother memorizing something else? But that's just how I think. So I like to teach my students the way that I taught myself. Because when the teachers are like, you have to memorize this, I would go home and figure out a way to not memorize it. That's just how I did, because my memory is garbage. Almost as bad as the video quality here. So here we are going to graph a secant, and just like I did before, I'm going to use its reciprocal because they are very closely related. The reciprocal of secant is cosine. There. Because there's a pi in my equation, there's a very good chance that my x-axis is going to simply go by ones. But first, midline and amplitude of the ghost cosine. Its midline will be at y equals -1. And its amplitude is 2. You may have noticed that a lot of my amplitudes are 2's. It's because it makes it easy to fit on the grid that I gave you. It's the only reason why. Since my amplitude is 2 and my midline is -1, I will let my y-axis go by integers. +1, +2, 0, -1, -2. I will have to go down to -3 because my midline of my cosine is y equals -1. I feel like this one was a wide graph if I remember correctly. Oh, no, not too bad. Okay. Next is going to be the period, so I can figure out the scale on the x-axis, right? The period is supposed to be 2 pi over b, so that gives me 2 pi over pi halves. Dividing by a fraction is the same thing as multiplying by the reciprocal. So this is going to give me 2 pi over 1 times 2 over pi. These pi's simply cancel, giving me a period of 4. Like that. So my quarter marks is just going to be the period divided by 4. My quarters are going to happen every 1/4 of 4, which is just 1. So, yeah, my x-axis can just go by ones. Hold on. You have a question, Ian? What's going on?
Oh, I was just noticing that this is the end of the notes. Like, what we've already done.
Yeah, this is the end of the notes.
So then, what happens?
Well, the sheet that you picked up today, no, we're skipping 4.6. You don't want to do it. The sheet that I don't even know how to do it. The sheet that I gave you today is extra credit for you to do over the weekend along with the homework. And on Monday, I'm giving you a 4-4 to 4-5 practice, which is sine, cos. It's all 6 trig ratios. And after that, I am giving you the test review on Tuesday of next week, because the test review is graphing and some of the material from the front half of the chapter. So on my paper, I have it called trig and spiral test review. So yeah, there is nothing to learn next week. Just we test at the end of next week. Yeah, this is the end of the material that I'm teaching you for this chapter. I'm sorry, there is no midterm for this class. We're just going to have the end of this chapter test. Okay? Alrighty. Yeah. What? What's up?
What are we gonna do when we have you for like 2 hours? Are we just gonna like do math?
Yeah, actually, I don't know. I haven't planned that far ahead.
We should just like.
What we're no, on the long day,
That's my birthday.
on the long day,
That is my birthday.
we will be doing something academic, I'm sure.
A cool math has the word math in it.
What's that?
What day is the class?
Your test is Friday of next week.
Just do on the long day.
All I'm saying.
Because that's a week after next week. I don't have time to waste with you guys. I have to teach you some AP Calc this year. Anyway, we're ruining the video. Okay.
Yeah, hi, Rylan.
Anyway, this thing needs to start at what makes the inside equal 0. So it is going to start at x equals 3. Now we're talking about the cosine wave. It is a positive cosine. So where does it begin? It's max. So it starts at its maximum and then it heads down. Cool. So let's see. At positive 3, we're going to be at our maximum of 1. And then midline. Then minimum. Midline. Maximum. And because I think it makes a good picture, I do want to get 2 periods on here. But instead of going further out to the right, I'm going to go left. Just the reverse order.
I'd start from the left and then go down the right.
Right, as long as you have this point here at x equals 3, you're good to go. And just like before, everywhere where this ghost function touches its horizontal, no, midline, excuse me. I was going to call it horizontal asymptote. Everywhere it hits its midline, the secant function will have a vertical asymptote. So that includes the y-axis this time. It's going to be kind of hard to see, but yeah, there is definitely a vertical asymptote on this y-axis. And I don't feel like going any further to the right. Time to turn the cosine wave inside out.
So it's everywhere. When you said inside out, you just mean like the opposite direction it's going.
Yeah, I feel like it breaks it and turns its pieces around. I'm making that term up when I say inside out. That's just the way it feels to me. That's not official math lingo.
You want to talk about what is official?
If you say it, it's official.
Oh, okay. Well, stamp it. It's official.
Guess my question. You're like basically God.
TM. Trademarked.
Don't you know how to make math?
I know.
Can you like make up math real quick? He's at 3. If he tries really hard, he might be able to go to 4. In terms of creationism. Creationism.
Easy peasy, right?
Inside out.
Great. So now that we have this one, shh, calm yourselves. We have 2 more questions to do. We have a tangent and a cotangent. Before I start the question, I do want to bring your attention back to the parent functions for a moment. You don't have to flip your paper because I'm flipping mine for you, because mine's right here. Here's the parent tangent function. Notice when we quote unquote started this question, the first thing we discussed was its zeros, right? And tangent happens to exist right at the origin. In all the questions we've done so far, all this challenging graphing questions, the thing that I told you to do is figure out what makes the inside equal 0, right? Because tangent of 0 is 0, sine of 0 is 0, cosine of 0 is 1, because it just told us where this thing was going to start. And as it turns out, tangent, yeah, 0. That one follows normal logic. But what is cotangent of 0? It's undefined. What that means is when we go to graph a challenging cotangent function, understand that when you make the inside equal 0, you're actually finding an asymptote because cotangent of 0 is undefined. It's the only one that works like that because when we do secant and cosecant, we graph the reciprocal. The tangent, what makes the inside equal 0 on tangent is a point, but cotangent, I'm going to say it one more time. When you figure out what makes the inside equal 0 for a cotangent, you have tracked down a point of discontinuity. I just wanted to put that out there. So let's get back to the question at hand. Now, tangent and cotangent technically don't have something called a midline, so I'm just going to call it the middle because it doesn't have a midline, but it still follows the same idea. Its middle horizontal line will be y equals 1. And since tangents don't have amplitude, I already know that my y-axis can go by 1s. And to be honest with you, the other ones don't even need values on them because only one matters. Awesome. Cool. All right, let's track down the period length. The period's supposed to be pi. So we find the period by doing pi over b. Our period is pi over the b value of 1/2, and dividing by 1/2 is the same thing as multiplying by 2. So our period length is actually 2 pi. Now, we don't need to find quote-unquote quarters for tangent waves because their period is only pi, right? And this one's period is 2 pi, but that doesn't matter. I'm still not going to use quarters. They're slightly different. So what I'm going to do instead is figure out where my phase shift is and then go from there. Yes? There's no such thing as amplitude.
True.
All that happens is this 3, even though it is a vertical stretch factor 3, all it does is it makes the curve get what looks like skinnier. It makes it go up faster and down faster. That's all it does. All right. Now this is going to be a very wide function. All right. My phase shift, what makes the inside equal 0, and I'll say quote unquote start at 3 pi over 4. X equals 3 pi over 4. Since this is a tangent wave, is that going to be on its middle line, or will that be a point of discontinuity? This is going to be on the middle line. Cotangent is the one that is undefined when the inside equals 0. So this is going to be the middle of the graph. That's where we're going to be. And you go, okay, I have a phase shift of 3 pi over 4, a period length of 2 pi. You want the period length and the phase shift to be in the same denominator. So we'll change this 2 pi to be 8 pi over 4. Looks to me like I should probably have my scale be in terms of pi over 4. So I'm going to build my scale at pi over 4. Right here will be negative pi over 4. And then positive pi over 4. I'm going to take it all the way out to...
The last one.
You want me to go to the last one?
Yes,
I mean, I could. It'll end at 3 pi. See, 1 pi over 4, 2 pi over 4, which is, pi over 2. 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4. 3 pi over 2. And 7 pi over 4. I'm going to be real with you. I feel like stopping at 7 pi over 4. And here's why. Whoa, I didn't realize my paper was so crooked. I'm sorry. Here's what we know. We know that we are going to start on our middle line when x is 3 pi over 4. So I have a point right there. The tangent function will always have a middle point directly between two asymptotes, and will always have an asymptote directly between two middle points. What this means is that this middle point is halfway through its period length. So we should have asymptotes half a period to the right, which is pi to the right, and half a period to the left, which is pi to the left. So our asymptotes, does that make sense?
Yeah.
Our asymptotes will be at our middle point, 3 pi over 4, plus pi, which is 4 pi over 4, so 7 pi over 4. We have an asymptote at 7 pi over 4. And our middle point, minus pi. Again, half a period to the right, half a period to the left. 3/4 minus 1 is negative 1/4, so negative pi over 4. Yes, sir?
So you just find out where it starts and then you add and subtract.
Half the period. Yep. Because the middle point is always going to be halfway between the two asymptotes. So I figured out where it's going to have a middle point, and then I cut my period in half. I went pi to the right, pi to the left. Boom. Yes?
I'm confused how you get like the pi thing. Like 3 plus 4. 3 over 4 plus pi.
The plus pi. Because my period, which is going to be the distance between my two asymptotes, is 2 pi, right? This is going to be directly between the two asymptotes. So pi this way and pi that way. So that'll give me my 2 pi. Yes?
So if the period was 4 pi,
Oh boy.
you would subtract and add 2 pi?
Yes, if the period was 4 pi, I would have added and subtracted 2 pi to that center point. I found an asymptote at negative pi over 4, and I found an asymptote at positive 7 pi over 4, which is why I stopped at 7 pi over 4, to be honest with you. And I'm going to pretend that it doesn't have a vertical stretch when I sketch this because I don't want to deal with it, because we all know what a tangent wave would look like, so it's going to look something like this. Could I be more precise? I could be, by actually figuring out where that would have equaled 1, or 2, I should say. I just don't feel like it. And how did I know that it went up to the right and down to the left? Because that is the shape of the parent tangent function, and since I saw no negatives in front of x and no negatives in front of tangent, I did not have any reflections at all. So its shape remained the same, other than the vertical stretching, obviously. And then there was 1.
Let's speed run this one.
No, I'm not going to speed run anything because in my mind, cotangent's the hardest one. Because cotangent is the one that you have to remember is undefined when its inside equals 0. This one's middle line is actually the x-axis. So I don't even need to put the green dotted line on there. I'll just do this. Maybe. So that reminds me that's where my middle line is. Okay? Because there's no number that's plus or minus out here. So my middle line's at y equals 0. And the period is supposed to be 2 pi over b. So our period is 2 pi over 2. I have a period length of pi. Oh, you're right. I'm sorry. Good catch. Good catch. Pi over b, not 2 pi over b, because this is cotangent. Pi over b is just pi over 2, so there's not even an equal sign necessary right there. There we go. Good catch. Period length is pi over 2. But our phase shift, yuck, our phase shift is a pi over 8. We want our period length and our phase shift to have the same denominator. So since I know I'm going to have to deal with the over 8, I'm going to call this 4 pi over 8. The point that makes the inside equal 0, the place where we are going to start, which remember, this is cotangent, so its starting place will be undefined, is negative pi over 8. Looks to me like I need my x-axis to go by pi over 8s. And here is negative pi over 8. I'm going to take this one out to 7 pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, and lastly 7 pi over 8. One last time, cotangent is undefined when the inside equals 0. So we are undefined at negative pi over 8. And the period length, which is how far apart the asymptotes will be, is 4 pi over 8. So 1, 2, 3, 4 pi over 8. And one more time, 1, 2, 3, 4 pi over 8.
Okay, how do you know that we have an asymptote at negative pi over 8?
We know there's an asymptote at negative pi over 8 because negative pi over 8 makes the inside equal 0, and cotangent is undefined at 0.
Okay.
So why are the asymptotes there?
Well,
Asymptotes
well, again, negative pi over 8 makes the inside equal 0, right? Cotangent is undefined when its inside is 0.
Yeah.
The period length, which is pi over 2, is the same thing as saying 4 pi over 8. So I just counted 4 of my pi over 8s over.
Okay.
And then I did it again to get the last one. The center point will be found halfway between the two asymptotes. So when they're at pi over 8 and the other one at 5 pi over 8, and the parent cotangent function looks like this. And since there was not a negative sign on the front of the 2, or a negative sign on either one of the 2's, I should say, I haven't changed its orientation. So yeah, it's still going to do that. And that's going to finish it up for today.
Bye, Rylan. I love you.